Okay, let me get this up on the screen. There we go. Hey. Okay. Hello, everybody. Welcome to Science, Matter, and Energy. Okay. Take out a piece of paper.
Could you please not say that? You know what? I'm gonna. Imagine the girl who made.
Okay. This reading quiz will go on 12 point or 13.1. Okay. Or maybe even 13.2. We'll see. Whichever I want. Okay, so here it is. 12 questions. You guys take the quiz, please. Come in quietly. Adrian, you're all done. Shh. Quiet, please. It's a strong request to be quiet. Is there anybody not finished? Okay. Yes, sir. Yeah. Here's your answers. We'll put this on 13.1. Okay. So, Derek, Andrew, Adrian, shh. 7. Amethyst.
12 out of 12.
Austin, Maya, Doug,
Oh, 8.
Sophia, Yuvia,
10.
Lena, Adrian,
8.
Gabby,
I got 8.
Ricky? Avery? Elijah? Okay. Okay. So yesterday we took a trip back in time, talking about chemistry. The reasons there. Now, we talked about. Well, here's a few reviews. Shh. What is the organized system or study of the composition and interaction of matter? Chemistry. Shh. What modern chemist proposes the atomic theory of matter? Huh? John Dalton. Guys, stop talking, please. What are any tiny particles that make up matter? Atoms. What are substances composed of single type of atom? An element. What are substances composed of two or more elements bonded together? What? Compounds. What are the building blocks of all substances in the universe? Elements. Okay. How many elements have been identified? 118. What are the physical combinations of elements and compounds? Mixtures. What are metal mixtures called? Alloys. What is a unique abbreviation given to each element? Chemical symbol. Good. Okay, Ricky, no more. Okay, here's where we're at today. 13.2, bottom of page 3 of your notes. Shh. Inside the atom. So let's look at structures of the atom first. Now, John Dalton proposed the atomic theory. Okay? So the question, or this first number one, the reason why Dalton's atomic theory was a milestone in the study of chemistry, everything that they went through back then, and here it is. Because it gave scientists an idea of how and why substances have their individual properties. So they were finding out, they knew all this, but now, or were starting to know it, and now John Dalton just kind of made it clear for them of why substances and how they had it have their own individual properties. Now keep in mind that as all of this was beginning to be developed, okay, beginning to be understood, man always has had a different recollection of different things, and so when they look at things, they have a perspective in mind of when it's basically like when you hear of something, you develop a picture in your mind of something, and until you went and saw that item, okay, before you went and saw that item, and talked about it, that was how you viewed what it looked like. But then when you saw it, it came into a picture. Well, the problem with Dalton's theory, atomic theory, was that he assumed that atoms were indivisible. Okay? Which means that since they were the smallest or a small particle, tiny particle, that they were like this little sphere that was going on inside things, and that
Plastic ball. Almost like a metal ball.
yeah, that's the idea, and that little ball could not be split. Okay, but as we found out later on in history, in time, that they were able to split the atom. Okay, but back then there was no technology to do it. So therefore, it just was basically this little ball, this sphere. Okay. Now, so it came clear. This is number 3 on page 4. That in the late 1900s or 19th and early 20th century, atoms were composed of smaller particles called subatomic particles. Okay. So number 4, inside the nucleus. The nucleus is the dense center core of the atom. Shh. What? Subatomic particles. Number 3. Number 4a, the nucleus is that dense center core of the atom. There's 2 types of nucleons, okay? The subatomic particles found in the nuclei, and those are called the protons and the neutrons. So the protons are labeled as P, and they are the positives. They carry the positive charge. They determine the identity of an atom. The number of protons in the nucleus is the atom's atomic number. So they determine that. And each atom has a unique atomic number. Shh, guys. Each atom has its own atomic number. Okay? And as when we start looking at the periodic table of elements, you're going to see that each of those have a different atomic number in them. Okay? Please have a seat. Sit down. Sit down. Okay? And that's 1 for getting up. The neutron is labeled with an N, small n. It's a subatomic particle that is electrically neutral with no electric charge. They are slightly a little bit more massive than the protons, but that's generally ignored in the situation. The different numbers of neutrons can exist in atoms of the same element. Okay. But atoms of metal, like atoms of metal magnesium, they always have 12 protons, but many contain 12, 13, or 14 neutrons. Atoms that are the same atomic number, but they may have different numbers of neutrons, are called isotopes. All the way. Okay, the protons determine the identity. Sorry. Are you done? Okay, so they're called the isotopes. These are the building blocks of the atom's nucleus. A third subatomic particle that the protons and neutrons are composed of are what we call quarks. Okay? Girls in the back. Final verbal warning. Be quiet. Yes. There's two types. Yes, sir. Yes. There's two types of quarks that make up the protons and neutrons. They are called the up quarks and the down quarks. Your up quarks are your subatomic particles with a positive 2/3 of a charge. And your down quarks are the subatomic particles with the negative 1/3. So by math, 2/3 and 1/3 makes up your whole 3/3. Sophia? Isotopes. Okay, Doug. Now, the charge of a subatomic particles are measured relative to the charge of a proton, called the elementary charge, and it's symbolized by the E, small e. Okay, everybody done? Now, there's 3 quarks that are needed to make up a proton or a neutron. A proton contains the up quarks and 1 down quark, giving it a positive 2/3. Okay, and that's where you get. This is where you get your 3. A neutron contains the up quark and 2 down quarks, in which the quarks electrically charged cancel out, causing the neutron, Doug, that's 1, to be electrically neutral. Now, quarks are held together by the color force, a form of nuclear force. It's much stronger than the force binding protons and neutrons to each other. An individual quark has never been observed, but through experiments they know that they do exist. Okay? So that's all inside the atom, the nucleus. Let's go outside. This is where we're going to find our electrons, or our E with the negative. Okay? Generally, we don't necessarily say the negative, but just for the book's sake, for note's sake, That's why they're putting it in here, just so that you remember that it is a negative. It's a subatomic particle outside the nucleus, and it carries that negative electric charge. Is equal, an electron's charge is equal to the positive charge, there should be a G in there, of the proton. They are much smaller and lighter than the nucleons, either one of them or both of them. They do not seem to be composed of smaller particles, the electrons don't, as the other ones are called the nucleons. They orbit the nucleus relatively far, making it mostly empty space. Okay. Now, if you want to put a picture to this, the comparison of the size of a nucleus of an atom versus the large sports stadium. The nucleus would be the marble in the middle of a stadium. That little white dot in the very center of the soccer, okay? The electrons would be they would be racing around through the stands of the stadium, okay? So in perspective of the nucleus and the outside of the nucleus, this is what it would, in a picture, would look like, okay? Outside the nucleus, you have what we call electron shells. These are all the layers that surround the nucleus. And this is where you would find all of the electrons. They're also called energy levels, because the more that you have, more shells, the more energy that the lower shells. And so as you go out, they get bigger numbers, more energy to them. So they're assigned with a letter, a number and a letter, okay? As you can see on this screen, can't see it on mine too much. Shell 1, shell 2, coming all the way out, 3, 4, okay? And then later on we're going to identify them with letters also. So the innermost shell is shell 1, or what's also called the K shell. The 2 shell is the L, 3 shell is the M, 4 shell is the N, 5 shell would be O, 6 would be P, and so on until we come to the end there, okay? Now, an electron shell can only hold a certain number of electrons. You find it by 2n squared is where the n is the number of the shell. So, shell 1 can only hold a maximum of 2, because it's 2 times 1 squared. Okay, 1 to the first power, 2 times 1. Shell 2 can hold a maximum of 8. 2 times 2 squared, 2 times 4. Shell 3 can hold a maximum of 18, or 2 times 3 to the squared. Now, look what we're doing. Each shell is the base of the square. 2 times 9. Shell 4 can only hold a maximum of 32. 2 times the 4 squared, 4 is the shell, or 2 times 16. If you keep going, number 5, shell 5 can hold a maximum of, it would be 2 times 5 to the 5 squared. So 5 squared is 25 times 2 is what? It would be 50. Okay? And go on up the line. Now, an atom normally has the same number of protons as electrons. Thus, it has no overall electric charge. Okay, overall. Influences like heat, electricity, radiation, chemical interactions can cause the atom to gain or lose electrons in the outer shell. That outer shell is also called the valence shell. So by its gaining or losing of those electrons gives it the charge that we would normally see on this. Okay? Okay. Okay. The screen froze on for the DLs. Number 2, the balance of the positive and the negative charges now has changed. So if an atom gains electrons, it's going to be more electrons than the protons, and therefore it's going to pass a negative charge. If an atom loses electron, it's going to have more protons, therefore it's going to become a positive. And so that's, like I said, that's how it gains or loses. That's how it changes its charge, by gaining or losing those electrons. Negative ions are called anions. Positive ions are called cations. So an atom that has an electric charge because of losing or gaining, I probably was going to underline losing there too, but that's okay. They are called, if they're losing or gaining an electron, they are called ions. So your negative ions are anions, positive ions are your cations. Okay, everybody with me? Number 3 there. Number 4, a substance that consists of ions is called ionic. Okay? And that's where we're going to leave it for today. Your homework tonight is just to read pages 312 to 315. Finish just a little early again. Okay? So, we'll see you tomorrow. Read it for probably a reading quiz. Okay, see you tomorrow.